The generalized linear model was proposed by Nelder and Wedderburn in 1972. The fundamental equation is that the expectation of y given a vector x is a function f of a linear combination of variables in the x vector. The dependent variable y does not need to be numerical, it can be categorical. F here is called the link function. Let's start with a sigmoid function. A sigmoid function f of x is equal to e to the x divided by 1 plus e to the x. F approaches infinity as x approaches infinity, and it is approaches 0 as x approaches negative infinity. If we let p of x be the probability that x equals 1, in linear regression we fit a model. P of x is equal to beta naught plus beta 1 times x. In logistic regression we fit the model. P of x equal to e to the z divided by 1 plus e to the z, where z is equal to beta naught plus beta 1 times x. And this is basically the sigmoid function that we saw previously. As the values of the sigmoid function are between 0 and 1, so we can use them as probabilities. To run a logistic regression in R, we use the function GLM. And once we have a model, we use a summary function to view the results. Given a fit model, we can predict by just plugging in the values. So first we need to extract the coefficients using the coefficients function. Then we can either predict for the linear regression model or the logistic regression model. We can also just use the predict function in R. Now let's see how we can interpret coefficients in logistic regression. Start with the probability p of x. After some manipulation, we arrive at p of x divided by 1 minus p of x on the left, and on the right side we have exponential e to the beta naught plus beta 1 times x. Taking a log on both sides, we get this. The ratio of p of x divided by 1 minus p of x is called the odds, always between 0 and infinity. The odd gives a relative measure of the probability. So if p of x is 1/5, then the odd is equal to 1/4. If p of x is 7/10, then the odd now give 7/3. The log of p of x divided by 1 minus p of x is the log odds or logit. And it's interesting that in a logistic regression model, the logit is linear in x. For a linear regression model, the interpretation of beta 1 is straightforward, which is the change in y associated with 1 unit increase in x. However, in a logistic regression model, it is more opaque. Beta 1 gives the change in the log odds per 1 unit increase in x. The relationship between x and p of x is not linear. Regardless, a positive coefficient indicates an increased probability as x increases. A multiple logistic regression can be run similarly as multiple linear regression by using the GLM function. The summary function then can be used to view the result. The interpretation of the coefficients is similar to the simple logistic regression model.